Think Central Lesson 813 is going to be all about the volume, figuring out the volume of composite figures. So it's first important to learn what a composite figure is, and then we can figure out how to calculate volume. Let's take a look at what a composite shape is. So a composite shape is two solid prisms put together. You can see in the book what they did as an example is they split the solid shape either this into parts like this, or they split them into parts like this. Either way, whatever is easier for you to find dimensions, that's what you'd use to figure out composite shape. So let's take a look at the first part here, number one, how they split it. So they split it this way, up and down. And let's get the dimensions for this prism right here. You know that the height is 9 inches that way, and you know the width is 3 inches. What you don't know is this dimension right here. So what you should do is all the dimensions are labeled in the shape. You just have to look at congruent or opposite sides. You see over here that's 5 inches. So if you take this dimension here, you know that this is going to be 5, this is going to be 5, and therefore this is going to be 5. So you know that the dimensions are going to be a 9 by 3 by 5 inch prism, and that would give you 27 times 5, or 130. All right, the second part of the composite shape is pretty easy to figure out because it already has the dimensions, but they tell you this is 15 here, so you have to understand that part of that is cut off. This part is cut off, and you know from this drawing that that is 3 inches long. So you have to subtract 3 from 15 to give you a dimension of 12 inches. So this second rectangular prism is going to be a 12 by 5 by 3 prism, and that will give you 180 cubic inches. So you're going to have to just simply add up the two separate volumes, 180 plus 135, to give you a total of 315 cubic inches for that shape. All right, let's go ahead and look at the second way they did it. You can see here they cut the prism across this way. So you have two pieces. You have a piece that's this shape here, and a piece that's this shape here. So first thing you want to do is let's just do the bottom piece, because that's all the dimensions are there for you. It's a 15 by 3 by 5. So 15 by 3 by 5. And you can put these in any order. It doesn't matter. So that would give you 15 times 3 times 5. It's going to be 225 cubic inches. Now, let's get the dimensions for the next part. You know that it's 3 here. You know that it's 5 across here, because that's the same and that's the same. So 3 by 5. But you don't know how tall it is. They did give you, the first measurement they gave you was this whole thing is 9. And you know that this is 3, so you subtract 9 minus the 3 to get 6 over here. So the dimensions of that would be 6 times 3 times 5, or 90 cubic inches. So you add up the 225 and the 90, and you end up with the exact same volume of 315. So either way you cut it, the volume of that composite shape is going to be 315. Let's start with our practice for the homework. They've cut the composite shape. They cut it right here. You can see that they took the entire shape and they cut it here. So we end up with two prisms, the blue one and the gray one. So let's first find the dimensions of the blue prism. So you know it's 3 and you know it's 11. So that's easy to put in there. But you don't know this distance here. Well, looking over here and looking down here, you see 5 inches. So that prism is going to be 5 inches wide. So it's going to be a 3 by 11 by 5 inches. So that's going to be 3 by 11 by 5. It's going to total 165. Now let's look at the gray rectangular prism. So the dimensions of that one, the 3 and the 5, are pretty clearly evident. So that's going to be 3 and 5. And what you don't see here is this one here, because the whole thing is 17, but you don't know what this little piece is here. So look up and then look over, and that will show you the S3. These are parallel sides and they're congruent, so 3, 3, 3. So that little piece is 3. So 3 and 14 make 17. So it would be 14 as a length. So 3 by 5 by 14 turns out to be 210 cubic inches. Then I just take this part and add them together. We have 165 cubic inches and 210 cubic inches to give you a total of 375 cubic inches for this composite shape. I included this page. This is ThinkCentral's explanation of the problem. You take a second just to read through what they did here. They came up with the answer, so we know that we're right. And it looks like they followed the exact same strategy that I had. But go ahead and read through this and compare it to how you would do it, because there are more than one way to do it. Let's take a look at number 2. The solids above have been decomposed, and by that they mean broken into parts, into different rectangular prisms. One of them is cutting it this way here, and one of them is cutting it this way here. What conclusion? The volume for each was found to be 315 cubic inches. What conclusion can you make from this information? So statement number 1 is a true or false. If you found the volume of the beige piece first, this one and this one, then you would have gotten a different answer for the total volume. Well, that's not true, because it doesn't matter how you cut it up. You're still, when you add them all together, you're still going to get the same volume. So that is not true. So I would cross that one out. Statement 2, statement B, you can put together different rectangular prisms to make the same composite shape. That is true, because they put together different things, but they ended up with the same composite shape. So that would be true. You can decompose a solid in different ways to find the volume. Well, that's exactly what they did. They broke it apart in different ways and they found the same volume. So that's true. The volume of the blue rectangular prism in solid 1 here is equal to the volume of the blue prism in solid 2. That's not true. They have different dimensions and they have different volumes, so that's not true. What they're trying to get you to think about here is you can break up composite shapes into different forms to calculate volume. All right, a little practice in decomposing shapes, composite shapes. So we're going to find the volume of this. A couple ways you could do this, or maybe I'll do it a couple different ways. The easiest one I see is to split it this way, but you could have also split it into 3 shapes. You could have split it this way and this way, but I think that the easiest way to do it is split it into 2 shapes, that way and that way. So we need to figure out the volume of the top prism and then the volume of this bottom prism. All right, let's take the top little box first. Let's find the dimensions of that box. So we know it's 5 and we know it's 3. So with the 5, height of 3, we don't know the length, but if you just keep looking along parallel lines, you see down here that they give you that dimension of 6. So the volume of the first box is going to be 5 times 3 times 6. 5 times 3 is 15, times 6, 6 times 15 is going to be 90, and those are feet, so it's going to be 90 cubic feet. Okay, now let's find the dimensions of the bottom box, the bottom prism. You can see that it's going to be 4 feet. You already have the dimensions here. 4 feet by 12 feet by 6 feet. So that's a 4 by 12 by 6 foot prism. So I did 4 times 12 is 48, 48 times 6. I went ahead and did a place value section model for this. 40 times 6 is 240, and 6 times 8 would be 48. So putting those two together, you get a total of 288 cubic feet. So adding up the two parts of this composite shape, the two different prisms, you have 90 feet plus 288 feet, and that would give you a total of 378 cubic feet as a total volume for this composite figure. I went ahead and included the ThinkCentral answer. If if you ever get stuck on Think Central, I always suggest that you use the view example. So this is a copy of their example. Doesn't show how they cut it, but explains how they cut it up here. And it's they cut it the same way that we did, and they ended up with the same total composite volume. For problem number 4, they're basically taking a composite shape, a laptop that's broken up into 2 parts. You have the screen, and then you have the keyboard down here. So that's how they're splitting up the composite shape into 2 rectangular prisms. The screen obviously is very skinny, and they're using centimeters, so they're small numbers, but it's the exact same idea. First, you want to find the volume of the screen, so it's going to be 0.5 centimeters times 37 centimeters times 21 centimeters. You don't have to, you can do this by hand, but since it's just practice for homework, and if you know how to, you don't need the multiplication practice, go ahead and use a calculator to help you solve this. Alexa, what's 0.5 times 37 times 21?
0.5 times 37 times 21 is 388.5.
So if Alexa was right, then that screen, the volume of that screen is 388.5 cubic centimeters. All right, so now let's figure out the volume of the keyboard, and the dimensions for that. It's a 21 centimeter by 37 by 1.4. So make sure when you're multiplying, you remember that there's 1 decimal point going on vacation to the islands. So when I multiply those out, I get 1,087 and 8/10. So now I'm just going to add up the volumes of the screen and the keyboard to get my total. So when I add those up, I get 1,476 and 3/10 cubic centimeters as my volume for this laptop. And that's how much the notebook would take up when it's closed. Taking a look at problem number 5, an in-ground swimming pool often has steps that are made of concrete to get up into the pool. In the sketch of the steps below, the steps are identical. So it's really important that you unpack that the steps are identical. That means they're all exactly the same length, width, and height, each measuring 18 inches from side to side, 14 inches from front to back, and 6 inches tall. So let's think about ways that we can split this up. If they're all identical, and I'm just going to split them up like that, and I'm going to split them up like that. So there's a couple ways we can solve this. We can see them as 6 individual steps. Oops, 1, 2, 3, 4, 5, 6. So 6 individual steps. So we find the volume of 1 step and multiply it by 6. That works. Or we can find the volume of 3 separate parts to it, like this, if I split them this way. So this would be the volume of 1, this would be the volume of the second one, and this would be the volume of the third one. So I'll do it both ways and show you the difference. So I calculated the volume of that first step, and it's a 14 by 6 by 18 step, and that gives you a total of 1,512 cubic inches. Now, the second step is the exact same thing, except it's not 14 by 6 by 18. It is going to be double the 6. So it's going to be 14 times 12 times 18 because it's 2 steps high, so 6 and 6. You can see that I multiply 14 times 12 times 18 to get 3,024, and that's the volume of this second step. You also notice that 3,024 is exactly twice as much as 1,512 because it's 2 times as high as the first step. All right, let's find the volume of this third step here. So you see that it is still 18 inches wide. It is still 14 inches deep because all these are the same, but it is not 6 inches tall. It is 3 times 6 inches because that's 6 and that's 6. So the total would be 18 inches tall. So the total volume of the third step you calculate by multiplying 18 times 14 times 18. And when I do the multiplication, I get 4,536. So the volume of that third step is that, the volume of the second step is that, and the volume of the first step is that. If you notice that the volume here, this volume is 3 times that volume. So when you add up all those, you're going to get the total volume of the steps. And when I add up the 3 different parts here, I get a total of 9,072 cubic inches. So let's take another look at another way we could do it that's actually easier, since they are identical steps. If you calculate the volume of the first step, which is 1,512, and you multiply it by 6, because there's 6 identical steps, you end up with the total same volume. So the volume that way is 9,072 cubic inches, the same volume as we had before. I think that if they are identical like this, this is probably the easier way to do it, as opposed to adding up the 3 separate pieces. All right, here's the Think Central reasoning behind it. They did exactly what we did for the first method. They found the volume of each individual step by splitting it up into 3 parts like that, and then added them together. So it's 9,072 cubic inches. All right, that is it for today. Figuring out composite shapes, breaking them down into, deconstructing them. That is going to be the answer and the end of the work for today. But go ahead and probably do a little bit of practice on this. As long as you can see how you can split the shapes up, then you are in good shape. All right. Thanks.